everyone. Hope all of you are doing well. In the last 4 videos, we were discussing the previous question papers and answers of the chapter Units and Measurements. Today also we are continuing with the same chapter. If you have not watched till part 4, please watch it before going ahead with part 5. Are you ready to go with the first question? The first question is asked in 2011 SAY examination. The question is, to measure distance, we use different units. Which of the following is the largest unit of length? The options are kilometer, astronomical unit, light year, and parsec. We have studied different units for measuring distance, right? So, which is the largest practical unit of distance? Yes, option D, that is parsec is the largest unit of distance. What is parsec? Yes, it is parallactic second and its value is 3.08 into 10 raised to 16 meter. Clear? Can we move to the second question? Okay, this question is asked in 2012 SAY examination. This is a 2-mark question and the question is, which measurement is most precise? The options are, first one, vernier calipers having 5 divisions on sliding scale. Second one, vernier calipers having 10 divisions on sliding scale. Third one, vernier calipers having 20 divisions on sliding scale. One more question is there. The question is, what happens to the accuracy when the least count is decreased? Here in the first question, we have to find the most precise measurement. Okay, what is precision? Yes, we have studied, right? So, what is precision? The limit of resolution to which the quantity is measured. So that as the resolution increases, the precision also will be increased. Okay, so we can go through the options. What is the first option? The vernier caliper having 5 divisions. Then the second one is having 10 divisions and the third one is having 20 divisions. So, as the number of divisions on the sliding scale increases, what will happen to the least count? The least count will be decreased, right? As the least count becomes very small, what will happen to the resolution? Yes, the resolution will be increased, right? So, which one will be having more precise value? So, here the vernier calipers having 20 divisions on sliding scale will be more precise, right? What is the second question? Yes, what happens to the accuracy when the least count is decreased? So, as the least count is decreased, what will happen to the accuracy? Accuracy also will be increased, right? So, the answer is accuracy increases. Now we can move to the next question. The question is asked in 2011 SAY examination. The question is, which one of the following measurement is more accurate and why? The options are 500.00 kilogram, 0.0005 kilogram, third one 6.00 kilogram. Here which one is having more number of significant figures? Yes, the first one, right? That is 500.00 kilogram, which has more significant figures. So, which one will be more accurate? As the significant figures are more, that will be more accurate, right? So, the first one is more accurate. That is 500.00 kilogram is more accurate because it contains more significant figures. Now, can we move to the next question? The question is asked in 2012 March. Okay. This is a 3-mark question and the question is, all physical quantities can be expressed in terms of dimension. Write the physical quantities of the following dimensions. 2 dimensions are given, so we have to write down the physical quantities. The first one is m1 L1 t raised to minus 1. Second one m1 L square t raised to minus 2. One more question is here. The second one is, check whether the equation t is equal to 2 pi root of m by g is dimensionally correct. Here t is the time period of a simple pendulum, m is the mass of the bob, g is acceleration due to gravity. Can we answer the questions? Okay, the first one is to find the physical quantities having the following dimensions, right? What is the first dimension? That is m1 l1 t raised to minus 1. So what does it mean? Mass into what is L t raised to minus 1? Yes, that is velocity. So what is the quantity? Mass into velocity. Which quantity is having the equation as mass into velocity? Yes, that is linear momentum, P, right? So the unit is kilogram meter per second. Therefore, one quantity we have got now. So is there any other quantities having the same dimension? Yes, we have studied some pairs, right, having the same dimension. So which one is the other quantity? Yes, that is impulse, right? What is the equation for impulse? That is force into time. How we can calculate? Force is, yes, mass into acceleration. So what will come? ml t raised to minus 2 and into time. So into t. So what we will get? Again it is m L t raised to minus 1, right? So these quantities, that is impulse and momentum, are having ml t raised to minus 1 as the dimension. Now what is the second dimension? Yes, that is ml square t raised to minus 2, right? Which quantity is having ml square t raised to minus 2 as the dimension? Yes, work, right? So what is the equation for finding work? Work is force into distance. So how we can find? Here force is mass into acceleration, that is ml t raised to minus 2 into distance means again into L. So what will come? ml square t raised to minus 2. So the dimension is ml square t raised to minus 2, that is work. And we have some more quantities, right? That is having the same dimension of work. Which one is that? Energy. That is all type of energy, kinetic energy, potential energy, etc. All are having the dimension of work. So we can write the second quantity as work. Is there any other quantities having the same dimensions? Yes, that is torque. How we can calculate torque? Torque is moment of inertia into angular acceleration, right? How we can find moment of inertia? That is mass into distance square. So what we will get? ml square. And what about angular acceleration? Yes, that is angular velocity by time. That is m0 l0 t raised to minus 2. So what will come as the torque? Torque is moment of inertia into angular acceleration, right? So that will be ml square into m0 l0 t raised to minus 2. That is also ml square t raised to minus 2. So we can write as the work, energy and torque are the physical quantities having the dimension ml l square t raised to minus 2. The next question is to check the correctness of the equation. Okay. So the equation is given as t is equal to 2 pi into root of m by g. So how we can find the correctness? Yes, we can apply the homogeneity principle. That means each quantity will be having the same dimensions on LHS and RHS, right? So that it is better to square the quantity because there is a root. So in order to avoid that, we can square the quantities. Then we will get it as t square is equal to 4 pi square into m by g. Now we can find the dimensions on both sides. So what we'll get? T square means the dimension also is t square, right? What about 4 pi square? Yes, 4 pi square is a constant, so there is no dimension for 4 pi square, and m by g is there. So what about m? M is having the dimension m, and g is the acceleration due to gravity. So what will be the dimension? L t raised to minus 2. So what we will get? The LHS is having t square as the dimension, and in RHS we have m l raised to minus 1 t raised to 2. Okay, so what we can conclude from this? Are you getting the same LHS and RHS? No, in LHS we have only t square, but in RHS we have m l raised to minus 1 t square, right? That means LHS is not equal to RHS. That means the equation is dimensionally wrong. Is it clear? Now we can conclude the video. If you have not subscribed the channel, please subscribe for more videos. Thanks for watching.